Hello, 7th graders. In today's lesson, we are going to be calculating experimental probability. So remember, experimental probability is the likeliness that an outcome is going to occur based on previous outcomes. And notice I just added that vocab word up here. That's going to be pretty important for today's lesson. All right, so we're going to start off with an experiment. If you could find a paper cup at your house and follow along with this experiment, that would be great. Doesn't have to be paper, could be just a plastic cup, probably not a glass cup, your parents would not appreciate that, but paper or plastic cup. So consider tossing a paper cup. Fill in the outcome column of the table with the 3 different ways the cup could land. Well, I'm assuming we have a cup kind of like this, probably a circular top, probably a circular bottom. So it could land on the top, upside down. It could land on the bottom, so right side up. Or it could land on its side. All right, I want you to flip the cup and record the number of times it happens. Flip it 20 times total. So these 3 boxes should add up to 20. All right, pause the video and do that. I'm also going to do that and record my outcomes. All right, so my cup landed on its top, so upside down, open and down, 4 times. Landed on the bottom, so right side up, 5 times. And it landed on its side 11 times. All right, let's reflect on this a little bit. Do the outcomes appear to be equally likely? No. My cup, I don't know about you, but mine was much more likely to land on its side than on the top or bottom. So let's describe the 3 outcomes using the words likely and unlikely. Now, my cup was much more likely to land on its side. I don't think it's necessarily unlikely that it'll land on its top or bottom. It's just less likely than it landing on its side. Okay, so we are actually going to calculate the experimental probability of these events. So notice this table here. They set it up for us to calculate the experimental probability. So open end up is the same thing as landing on its bottom. My table's a little backwards. And then open end down is the same thing as landing on the top. So mine landed on its bottom 5 times. We can simplify 5/20ths to 1/4. It landed on its top. So open and down 4 times. 4/20ths is 1/5. And it landed on its side 11 times. I cannot simplify 11/20ths, so that would be my experimental probability. All right, so now we're on number 4, make a prediction. What do you think would happen if you performed more trials? Well, it would probably land on its side about half the times, like it did here. And then it would land on its top or bottom probably about 1/4 of the times, like it did here. And what is the sum of the probabilities in number 3? Well, if we add up 5/20ths, 4/20ths, and 11/20ths, we should get 20/20ths. Which makes sense. If you have all of your outcomes, the probability of each outcome happening should add up to 1 or 100%, because that covers all possible outcomes. So you can use experimental probability to approximate or calculate the probability of an event. Experimental probability is found by comparing the number of times an event occurs to the total number of trials. Just like we talked about on the last slide, the numerator is the number of times it happens, and the denominator is the total possible outcomes. And notice that formula is given right here. We're going to use this a lot today and tomorrow. All right, so experimental probability, number of times the event occurs over the total number of trials. All right, let's check out our first example. Martin has a bag of marbles. He removed 1 marble at random, recording the color, and then placed it back in the bag. He repeated this process several times and recorded his results in the table. Find the experimental probability of drawing each color. All right, so it looks like there were red, blue, green, and yellow marbles in the bag. He pulled a red marble 12 times, a blue marble 10 times, a green marble 15 times, and a yellow marble 13 times. So the first thing we have to do when we're calculating experimental probability is add up all of the frequencies and find the total number of trials. So notice that that's this step here. The total number of trials is 50. So 12 plus 10 plus 15 plus 13 is 50. Total number of trials is 50. All right, the second step is to then make the experimental probability. So we know experimental probability is the number of times the event occurs over the total number of trials. These are the number of times the event occurred. This is the total number of trials. So the probability of pulling a red marble, it was pulled 12 times out of 50 total. Yes, we are going to simplify that. The experimental probability of pulling a red marble is 6 over 25. All right, the blue marble was pulled 10 times out of 50 total trials. So the experimental probability of pulling a blue marble is 1/5. The green marble was pulled 15 times out of 50 total. 15 over 50 we simplify to 3/10. And the yellow marble was pulled 13 times out of 50. We can simplify that. So let's reflect a little and think back to the idea of complement events from our last section. What are two different ways you could find the experimental probability of the event that Marvin does not draw a red marble? So remember, the probability of the red marble was 6/25. You could either find that by subtracting 6/25 from 1. So 25/25 minus 6/25 is going to be 19/25. The experimental probability that Martin does not pull a red marble is 19/25. Or you could add up all of the other probabilities. So you could add 1/5 plus 3/10 plus 13/50, and you should also end up with 19/25. So to find the probability that he does not draw red, you could either subtract the probability that he does draw red from 1, or you could add up all the other possible events probabilities. All right, your turn. I would like you to pause the video and try to complete number 7. On your own, you are finding the experimental probability of landing on each color. All right, so I'm going to solve it as well. So pause the video if you haven't done so yet. All right, and hopefully you're playing it now so that we can find the experimental probability together. First, we need to find the total number of trials. So total trials. And we get that by adding up the frequencies. So 10 plus 14 plus 6 is 30. There were 30 trials total. So the probability of spinning a red is 10 out of 30, or 1/3. That was an equal sign. The probability of spinning a yellow was 14 over 30, or 7/15. And the probability of spinning a blue was 6 over 30, or 1/5. All right, so we found that by putting the total number of times it happened over the total number of trials. So total outcomes over total trials. All right, so next we're going to talk about making predictions with experimental probability. A simulation is a model of an experiment that would be difficult or inconvenient to actually perform. So it's like you're pretending to do the experiment. You can use a simulation to find an experimental probability and then make a prediction of what would happen in the actual scenario. So let's look at our example. A baseball team has a batting average of .250 so far this season. That means that the team's players get hits in the 25% of their chances at bat. Use the simulation to predict the number of hits the team's players will have in their next 34 chances at bat. So when we do a simulation, first we're going to choose a model. So for this example, we chose a deck of cards. Cards have 4 suits: hearts, diamonds, spades, and clubs. And since a quarter of the cards are hearts, you could let hearts represent a hit. So a quarter number of the cards represent a hit because 25% is the same thing as 1/4. and their chances are that a fourth of the time they will hit when they're at bat. So then you would perform the simulation. To do that, you draw a card at random, and you put it back, and then you draw again. You don't keep it out because then it's no longer 1/4. It depends on the card you chose. But you continue until you've drawn and placed 34 cards total, because they say 34 chances at bats. That's why you're performing it 34 times, is because you're simulating 34 chances. Okay, so then you record the times that it was a heart or not a heart. And they recorded diamond, clubs, and spade, but you could just record not a heart as well. And the times that it was a heart represent the times that they will actually get a hit while they're at bat. So if you count the number of times hearts occurred, it occurred 11 times out of 34 chances. So you can predict that the team will have 11 hits in its next 34 chances. All right, let's read through this number 8 together. A toy machine has equal numbers of red, white, and blue foam balls, which it releases at random. Ross wonders which color ball will be released next. Describe how you could use a standard number cube to predict the answer. Well, to make a simulation, we want to find something that has equal chances of 3 different outcomes. So with the toy machine, it has equal chances of being red, white, and blue. That means that theoretically, so not experimentally, but a third of the balls are red, a third of the balls are white, and a third of the balls are blue. So we would want to simulate something that has similar probabilities. There are 6 sides to a number cube. So to simulate a third of the chance, we could say numbers 1 and 2, we're going to pretend that that would be equivalent to a red ball. Numbers 3 and 4, we would pretend would be similar to a white ball. And then numbers 5 and 6, we would pretend are blue. So then we would record which numbers happen the most, and then we would use that to compare the experimental probability of red, white, and blue foam balls from the toy machine. All right, thanks for watching the notes video, guys. Your job today is just to submit notes, but make sure you tune into the Google Meet to get some practice examples and then to see what your assignment is for tomorrow.